Hello and welcome to this SOFiSTiK tutorial. In this video, I want to show you the different types of parametrization you can do in a Revit family to optimize your working with the SOFiSTiK Bridge and Infrastructure Modeler. So when I talk about parametrization, what do I actually mean in regards of working with the SOFiSTiK Bridge and Infrastructure Modeler? First up, one of the examples I chose is the height development of a superstructure. The two-dimensional cross-section, which is the base for your superstructure, can be created in a way that the defining points for the height of the superstructure vary according to a parameter, which can then be controlled by the SOFiSTiK Bridge and Infrastructure Modeler. Next up, another example would be the width development of a cross-member. The cross-member that is placed along the axis in an interval can vary in its width along the axis alignment. The next example I chose considers a variation of parametrizations, like height, distance, angle, and alignment variations of the columns. So this can be controlled in this case not only by one axis but also by considering a secondary axis as well as multiple variables along the axis. You can choose on your own for every family that you create what kind, type and level of parametrization you want to consider. To give you the right tools to work with, I prepared 3 types of parametrization that you can use for your individual SOFiSTiK Bridge and Infrastructure Modeler families. The first one I want to talk about is aligned dimensions. Aligned dimensions can control reference points based on dimension lines that you place in the same plane as the point you created. I also created a list of pros and cons. In my opinion, the pros for aligned dimensions are that you can, for example, display the name of the parameter that is used to parametrize this reference point. The dimension lines can be created in the same plane as the reference point, so there is no need for separate plane assignments. One of the disadvantages of this method is that the dimension lines that are used to parametrize the point can only display positive values in the direction the dimension line was created. So there cannot be negative values assigned to this dimension line. You must follow a strict order when you create the reference points and when you create the dimension lines accordingly. Points that you want to use as a reference but already have existing constraints might not allow you to create additional constraints via aligned dimensions. Lastly, too many reference points that are parametrized via aligned dimensions might clutter your family. One point to be properly parametrized requires a horizontal and vertical dimension line. So keep in mind to only use it when you want to display the variables that are used for this parametrization. Let's take a closer look at how to use this method in Revit. Here in Revit, I will now create a new adaptive family, specifically a metric generic model adaptive. And the first step is to create a reference point. I like to align them to the origin of my family and then make them adaptive. This will be my reference for the axis placement of my family later on. We always work from the left to the right. So to create a reference point, I must select a reference plane. In this case, I select the plane which goes from front to back. I select this plane and can now place somewhere along the line my reference point. The next step now is to use the same reference plane to place dimension lines. So I can once more reference my adaptive point and my reference point to create these references. You can see that the point, once I select it, can be controlled via these reference dimensions. And the next step is now to create parameters. You do this in family types. Once we enter family types, the first step that I usually recommend to users is to create a new type, simply because that way the program doesn't have to determine a type for you later on, which saves memory space. So actually I'm happy with the name type 1, and I will ignore these kind of parameters because I want to create one parameter for vertical. This is the name of the parameter itself. We could create type controlled parameters, but in this case I want to create every single instance of these parameters via my value input. I want to create a length parameter. You can see that there is a variety of parameters that can be created, and the grouping is simply a matter of organizing your parameter in the family. Let's click on OK, and here we now have our vertical parameter. I want to create a second one, which is horizontal. And this one will also be an instance parameter. For now, I will not assign a value to them because, as you can see in a second, I can select this dimension line, and up here in label dimension, I can now reference my parameters. Once I set them to a specific value, the dimension line will override the assigned value of horizontal. We can also check this in family types. And in here, the value is now overwritten. I will now also select vertical for the vertical offset of my point. Now I want to control horizontal and vertical via a formula. So let's open family types. Here you can see that on the one hand we have a value input. On the other hand, we could control these values with a formula. Let's just quickly assign horizontal to my vertical, and let's say vertical is just horizontal divided by 2. We can see that the value of the parameter immediately updates. Let's click on OK. And here we can now see that vertical has assigned a new parameter and the reference point follows the set values. Let's change it to something like 2500. Click on OK. And we can see that both horizontal and vertical update accordingly. So as a quick summary, keep in mind that we are working in this plane of the adaptive point. We create a new reference point that can then be controlled via horizontal, vertical dimension lines. The second method I want to talk about is reference points with offsets. On the one hand in Y direction as well as in Z direction. And here you can see that you require one point with an offset in the direction of Y. In this case, you can see that it is in the negative orientation of the origin point, as well as a separate point for the Z direction. So let's take a look at the pros and cons of this method. Pros, these points can consider values in the positive and negative direction of their orientation. With reference points with offsets, you can consider more constraints or different kind of constraints compared to the aligned dimension, like the rotation angle or the offset, or flipped or mirrored. And you have a clean handling of the family. So there is no indication of the referenced parameter directly in the geometry of the family. On the other hand, cons. Positive direction of the coordinate system must be kept in mind and considered, meaning that both the origin point as well as the reference point created will need to consider the offset in the right direction by considering it positive or negative. Secondly, it requires one point for one operation. Here you can see that the referenced plane for the creation of the point considers a negative offset into the direction where the reference point is then placed. Lastly, complex operations with this method requires complex formulas. Let's check once again the picture from before. So here you can see that there is an adaptive point as an input reference for the first point. You can see the positive direction of this point pointing to the left, and the positive direction for the Z orientation of this point or the coordinate system is to the top, meaning that the Y distance to our point must be a negative value, and separately from the coordinate system of this point, we create the second reference point with a negative z direction to this point. Additionally, I want to take special note to the rotation angle. So here we have our adaptive point. This is the one we start with when we create an adaptive family. When we assign a point in the right plane and assign a rotation angle, this point can now rotate. So meaning that the rotation angle, depending on the plane that we select, is displayed here. What we can do next is we can create an offset from this point to display very complex situations very easily, meaning that we don't necessarily always need a horizontal and vertical point, but we can also rotate the existing plane of the point. Here in Revit, I now want to continue with our existing point. So this point shall be my new reference, and to easier display it, I want to show the reference plane of my new reference point. Next up, I want to talk about the planes. You can see that this reference point has a plane in the orientation of our input, this plane here, a longitudinal plane and another longitudinal plane aligned to horizontally. The way that offsets of reference points work is that they work orthogonally to the selected plane. So let's create a vertical offset for a new point. Meaning I reference the horizontal plane and I create a new point element, simply clicking onto this existing point. This warning will pop up, which makes a lot of sense. There are identical points in the same place. Lines created from these points may not work as expected. That's exactly what we expect. You can always just click OK for this warning. I can now hover over to my point and click Tab to click onto my new reference point. I can now move it simply by aligned planes to create the offset. Keep in mind, the offset is always the distance from this plane to our new reference point. And the same way as we created these dimension lines, we can now assign a parameter without showcasing this parameter separately in a dimension. To do so, I will go to my family type and create a new parameter, which I will call reference v, which is an instance parameter of the type length. Click on OK, and I can give it a value of, let's say, 3000. Click on OK, and this change is applied to the family. We can now select the reference point and assign this offset parameter to reference vertical, reference v. We can now see that the offset is set to 3000. The change becomes apparent when we set it to a negative value. If we set it to a negative value, we will now, in reference to the host element of our reference point, let's quickly show the host of this reference point, we can see that the offset from this plane is now set to -3000. Let's continue with a more complex operation, which we can also very easily showcase when we show the reference plane of this point, because now I want to assign a rotation to it. First off, let's create a new parameter, which we will call rotation. This is an instance parameter of the type rotation angle. I click on OK, and I can assign a parameter to it. Let's set it to 10 degrees. By clicking OK, this parameter exists in the family, and all I need to do is to select the right plane for my rotation. I can of course set it into all directions, but I will stay in this plane looking from the left onto the plane left-right. So I select this point's reference plane and I create a new point. Again, the warning will always pop up when we create two points in the same place. And this point I can now assign the parameter rotation in rotation angle. Once selected, we can see that the coordinate system of this point changed, but the planes didn't, because the planes are still from the original point, which does not have the rotation, but it has the offset assigned to it. We can play around with the displayed planes of the reference points by turning them on and off. And it's very easy to identify the separate points, because you can see here, this one point that I selected has no offset, but it has a rotation angle assigned. Let's activate the reference plane of this point. And here it now gets very straightforward. We simply select the plane we want to create an offset to with this point. I select a new point, click on OK. Via tab, I select this point and I can see here it has a rotated coordinate system, but it is aligned to the original plane of our rotated reference point. So in here I can once again give it a parameter. In this case, I will give it the vertical offset of our other point, so we can reuse parameters, of course. And here you can now see that this point, if I change the rotation of the other defining point, will always properly align to its host. Again, we can show the host by clicking up here. And it always follows the defined offset. So if we were to change any of these values, all of the parametrically created points will follow. While creating lines between 2 points, you must be careful to only select one of them. The easiest way to do that is to simply select the planes of a single point. Don't try to connect them like that, because the spline will try to connect all points that are here. And just for you as a little reminder, we have another point located here as the host for our rotation. So keep in mind to only select one point, and that way it's very easy to create references, for example, a superstructure. By the way, if you want to get rid of this connection, simply click on dissolve. So this way, instead of deleting all the connecting points, they will keep their original parametrization. The third method I want to talk about are reference lines. These reference lines can combine multiple functionalities into a very simple line-based connection. So when we talk about reference lines, we have a couple of pros and cons to consider. Reference lines have a start and an end point. In between those, the lines are created, and both the start and end point can be parametrized with the other methods I already showed. It is easy to create very complex parametrizations, or it's a simplified way of creating very complex parametrization using reference lines. The cons, on the other hand, are you need to keep in mind which reference plane you're right now working in, because both the start and end point, as well as the reference line itself, has reference planes that will be prioritized while creating new points. And it's advanced handling to create your geometry. What do I mean with that? For example, when we create reference lines, we have the option of simply placing a point on the reference line. This point will now get a reference to the planes of this line, which means that we can tell the program from the beginning, so the start point of the line, we want this point to have a normalized curve parameter offset of 0.5. This means 50% of the length of the line, no matter the length of the line. Meaning that this is a percentage-based calculation where this point will be placed along the line. We have multiple options. We have segment lengths where we can then assign a specific offset from the start, or you can of course also change it from the end. In my opinion, the most powerful application of reference lines is to create points at specific intersections. Meaning that the point itself once it's placed onto the reference line, gets additional modify options. You can see them here in the green bar, where we have the option to host by intersection. This is especially powerful as it doesn't matter to the program how complex the intersection between the two lines is, it will still find the intersection and align the point accordingly. Here back in Revit, I now want to extend the functionality of my already existing reference points with additional reference lines. Let's say I increase the distance that this point is allowed to offset from the origin point. For example, by assigning the horizontal parameter. What I can do now is I can select one of the points that we created down here to create a new spline in between 2 points. This line can now either be referenced for a creation of a volume later on in the project, or I can simply set it to reference lines. A reference line will not create any kind of geometry in your project, it will just be invisible, but it can still be a reference. So you can click it in your project later on, or you can set this parameter to not a reference, so it won't be clickable, which is usually the case for the lines that I personally create. I can now select the original point from before, from our dimension line driven reference point and our origin point. I can create a reference line and set it to not a reference. So let's play around with these reference lines. When we now create a new point element, you can see that I can directly reference one of these two lines without setting a work plane. If I click onto one of them and select the point, you can see that the standard setting is normalized curve parameter. I can also set it to segment length, and here you can see from the beginning it has an offset of 2000 millimeters. If I set it to 2000 directly, you can see that it moves accordingly, and if I were to place a dimension line from my start point to here, you can see that it's exactly 2000. This can of course be freely changed. So you can see that this little rectangle over here also allows me to assign a parameter to it. So this is something that you can already use to create an aligned point which follows a specific rule. So very easily I could, for example, change the rotation to 30 degrees and the point will move according to the reference line. Let's now select this reference point, and instead of it to be driven via measurement type, I want to host it by intersection. The program now down here gives me the instruction to select the second curve, and by selecting it, the program will automatically find the intersection of these 2 points. If I now once again change the alignment or change some parameters here, for example 3500, the program will automatically and quickly calculate the intersection and place the point there. Be careful when you work with reference lines though, because you can see that the clicking of this line is very easy. So I recommend, if you want to create additional points that should follow, for example, dimension lines or offsets, I like to temporarily hide these elements for simplification of not clicking them. You can reset it or select both of them to hide them. If you now were to create references for your geometry creation, I recommend to simply select the points here and the according geometry will follow the points, and you can see they are a little harder to see here now, but believe me, you can very easily modify everything accordingly here, and the geometry will update as well. The parameters we created in this family can be categorized into 2 categories. The first category is the one that is directly user accessible and can be accessed directly in the SOFiSTiK Bridge and Infrastructure Modeler in Revit. There you can either assign a fixed constant value to these parameters, Or you could assign a station-based variation of these parameters along your axis beforehand as a variable, and assign them right here to these parameters to vary along the axis. Lastly, the parameters that are defined via a formula cannot be directly accessed in the SOFiSTiK Bridge and Infrastructure Modeler. They are going on in the background, so forth. They control everything that is going on in the background of the family, with no need for you to access them in your main project.